Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the most important aspect of designing a database, that is the entity relationship diagrams or ERD. We will discuss about what is an ERD, what are the basic structures to compose an ERD, how to map the cardinalities, put the constraints in ERD, and then we will know about the basic simple ideas behind the ERD to form a small enterprise to a big enterprise like universities. As we know that database management system is all about managing a database for a particular enterprise. Now, when we talk about enterprise, we know that the entities are the objects or the minimum unique values that we can calculate on anything about. Now, to see that what are the relationships that an entity has with another entity in an enterprise, say suppose the student has a teaching relationship with the teacher, as well as the administrator has a pay relationship with an employee. So in this way, we relate the entities with each other so that we can calculate and design the database smoothly. Now, entity relationship diagrams is a simpler and clear idea about the database of designing this part as a whole logical view of the database. So ERD provides an overall design for the database which represent the logical relationships between the entities that exist in that particular database. Now when we talk about the ERD, we need to know about what are the features or what are the structures that we use in the composition of an ERD. Now, the first compositional idea are the basic shapes that we use in ERD. So, the basic shapes that we use are as follows. First is the undivided rectangle, and it looks like so. When we talk about an undivided rectangle, first we need to know about the division. So, divided rectangle, then we will form the undivided rectangle. So the divided rectangle gives us what is the relation and what are the attributes in the relation. So that is the basic entity of an ERD is the divided rectangle. So it gives relation as the first part of the division on the rectangle and then followed by the attributes on that particular relation. So relation wise, table wise, it is the basic form of an ERD. Next we will move toward the undivided rectangle. Now if the rectangle is an undivided one, it consists of some logic structures in this. So it consists the logic structures. It could be a program, it could be another statement, it could be anything but a logic structure that an entity maintains, or we can say it is the behavior of an entity in the ERD. Next are the relationships or the diamond. Now, diamonds represent the relation between the entities. Next are the lines. If a line is from one undivided rectangle or for a divided rectangle to another one, then we represent it with the line. Now, the line represents that the relation is going from this relation to another relation. So it actually joins two relations in a single diamond or relationship. Now, as I have mentioned that the line represents that we are joining two relations. Now, what if I want to join one attribute to a relation? So that will be done by this dashed line. So the dashed line actually joins an attribute of a relation to the relation. See, when we will develop the ERD, the basic structure will contain this divided rectangle as the relations, but actually we want to glorify it or actually expand it with more details or as much details we can put in it. Now when we are putting the more details, so then we can divide it into the attribute wise. So when the attribute is getting joined to the relation, then we can join it with the dashed line. Now when there is a double line, then we can say that there exists a total participation from the entity to the relationship. That means that the total entity is the entire relation. That means if an university is the relation that we are talking about or an enterprise, then it actually gives us the study. So study is the relationship that is the total participation. So here we are considering the final output of that particular enterprise. If it is a bank, then the monetary explanations are the total relationship. So this represents the total relationships with an entity to a relation. Now, if there is a double diamond, then it represents that the relationship is being made with a weak entity set. We will discuss weak entity set later. For now, we know that it relates our relationship with the weak entity sets of a particular ERD diagram. Now let us look at a fixed and divisible example to start an ERD. Now, in this example that we are talking about, we are considering an instructor relation that has a relation with the student relation. Now, the instructor relation is represented by a divided rectangle with the instructor as the relation name and ID name and salary as the attribute name. Same goes with the student where ID, S name and total credits are the attributes. Here we can see that I have underlined the primary key of each of this relation. Now you can also underline if there is a group of keys for the primary key. Now, what is the relation between an instructor and a student? An instructor is always being an advisor to the student. So the relation between the instructor and the student is the advisor one. Now, this advisor relation cannot go for the vice versa, that a student cannot be an advisor to the instructor. So we have to rectify it, that we need to put an arrow here. That means the advisor relation goes from the instructor to the student, not the student to the instructor. Now, what if the represented in an ERD, if I want to add in this ERD that at what did the instructor become an advisor to the student? So it is not meant that every instructor is an advisor to every student. Say for an instance that a student is getting admitted to the 5th semester of an university. Now when it is done so the instructor at particular that date become an advisor to the student. So how to add this relation into an ERD? Let us see how to do this one. Now, an attribute is represented by a small square or rectangle in this ERD. So that date is particularly an attribute that we want to add to the relationship, not to any of the relations. So these things you need to handle very carefully, that the attributes when we are adding to the ERD, that means there are already attributes for the relation. Now I want to add an attribute to the relationship so that the relationship becomes more specific. So the problem that was previously defined, that I want to add, that when particularly the instructor become an advisor. So the problem is dealing with the relationship advisor, not with the relation instructor and student. So now an attribute will be added as prescribed in an ERD structure with a dashed line and a small square or rectangle. So in this way, I have attached the attribute date to the relation advisor to specify that advisor has become in this date the particular instructor. Now we have to look that about this arrow. So when I am signifying this, I can say that one instructor can be an advisor to many of the students. So it is basically suggesting the relationship of one to many. So one to many, when is the left hand side is the single relationship holder, to the right hand side of the ERD, which represent the many relations can exist. So for one instructor as the advisor, there can be many students. Now we will see that how to handle a many to one or a many to many relationships that exist in the ERD. When we talk about many to one, that is the exact opposite of this one to many. If there are many students that can be attached with a single advisor, then it's said to be a many to one. We can just reverse the diagram like this. So if the arrow goes like this, that many student can be learner to a single instructor. So we can also deal with like this one as a many to one relation. So both one-to-one and many-to-one are of same kind, just the relationship changes for each of the relations. If it is from the left to right, then there should be another relation for the right to left relation. Now we will see that if there is a one-to-one relationship, how to handle this one. Now if it is a one-to-one, then there will be arrow to both the sides rather than using arrow to one side. That means an arrow to here to here. That means one instructor can be the advisor of only one student. So if the arrow goes to both the side, then we are defining a one-to-one relation. Next comes the many-to-many relation. When we are talking about many-to-many, that there can be many instructors who can be advisor to many students. So we simply do not put any arrows to our ERDs. So that will specify that many students can be the learner of many instructor, or many instructor can be the advisor of many student. Now we will simplify this relationship with an extended or more complex ERD. So for complex ERD, we will consider not just the undivided rectangle, but now we will simplify each of the attributes as a part of the relation. So we can represent it like this way. So between a customer and loan relation, we can say the relationship is the borrower. So a customer can be a borrower to the loan. So if I want to define the one-to-many relation in this way, so we can say that a customer can get many loans from a bank. Now that we are specifying this relation, so we need to put the arrow in this way. But what about the attributes? Now we will add the attributes to the relation, as well as we can do it with the relationship too. So now as the attributes are added to the relation, we will represent the attributes as an oval shape, and it will be just linked with the relation with a line, not a dashed line. If I am using the dashed line, then it is representing that I am adding the particular attribute to the relationship. So now we will add all the attributes that we can add to the loan as well as the customer relation. So the attributes to the customer are the name, ID, street and city of the customer relation. See, for the designing part or for the drawing part, it is always advisable to put all the attributes in either side of that particular relation. We can use either the upper side or the lower side. It is not advisable to put the attributes in a jeopardized manner, like even with the upper and or the lower side. So if there are more attributes, then we can put it like this way, but it is always good to put the attributes in one side of the relation. You can use the upper and lower both, but you can put all the values in the upper side. So this is the basic relationship of an one-to-many or many-to-one according to this way. Now if we change this arrow from there to there, then it suggests that there are many loans that belong to one customer. So if we can change the arrow of that particular one-to-many or many-to-one relationship to suggest that from one side we have the many sides on the other one. Now we will put that how to use a one-to-one relation in this way. So if I want to draw that a single customer can have only a single loan from a bank, then we need to define the one-to-one relationship between them. So we can put the arrow from this one as well as this one. That means only there is one customer to the borrower and one loan to the borrower or that particular customer. And we can add all the attributes like in the previous way. So I'm not doing this here. That's it. All attributes can be added up as this. So that is for the relationship between in the relations of the ERDs. Next we will talk about the cardinality in the ERDs. Now we can use the cardinality in the relationship like in this way that we have put the relationship in a drawing one. So we need to define all the cardinals in the lines that are joining an attribute or a particular relation to the relationship on the diamond of that particular ERD. Let us see how to perform this one. Now again I am considering the customer and loan relation. So for the denotion that we will use in our cardinality are that we will use L for the lower limit to put on, H for the highest limit to put on. So if we have that L and H as specified with a dot sign. So L dot H is my lower and higher relation or the cardinality to the relation. If I put the higher as the star one or asterisk sign, then we are specifying that the relation has no limits. That means it is actually specifying that one-to-many relation. Now if I put 1 as the higher limit, then we are specifying that one-to-one relation, that Any of the relation can be attached to one of the relation in the next part. So we can write it like this way. So when I am doing this, I am specifying that the lower limit to the customer is 0 and the upper limit is star. That means we can have any number of customers that is related to either a minimum of 1 to the highest age that is specified by the user or the database designer. So in this way, we can establish the cardinality to our relation. Next, we will talk about how to go for a derived entity. Now, if we are talking about a derived entity or derived attribute, then we are saying that an attribute that can be derived from another attribute. See, when I'm saying age and date of birth in a particular relation. So date of birth is a main of the attribute that we are having in the relation, and age can be derived from the date of birth. That the current date subtracted from the date of birth will give us the age of that particular person. So age can be a derived attribute to the date of birth field or attribute. So how to represent it in this ERD? We will see by solving a problem. Now let's look at this one. We have a customer relation. See, it is not about the relationship now we are considering with this problem. We are actually having the derived, the multi-valued and the multi-part attributes in this way. So first we will talk about the derived attribute. When I am representing a derived attribute, I should write it with a dashed oval sign. Now, the dashed oval sign of age is representing that age can be derived from any of the attributes present in this customer relation. So we can see that age can be derived from the date of birth or the date of birth of that particular customer. So date of birth can be represent the age. Now we will talk about multi-valued attribute. When I'm talking about multi-valued attribute, then we are mentioning that the value attribute of that particular relation can have more than one portion. That means a person can have more than one phone numbers. So the attribute can has many of the values to be attached with this relation. So now to represent the multi-valued attribute, we should use a doubled oval line. So in this phone number field, we should write a doubled over to signify it as a multi-valued attribute. Now we will cause about the attribute which has many of attributes related to it. Say the CID is an atomic attribute. That means it cannot be broken further. It is the primary key of the relation customer, so I am underlining it with this way. Now, the name can has many attributes. The address also can has many attributes. First, look at this attribute and their parts. So a name can have first name, middle name and last name. So this type of attribute is considered to be a composite attribute, which is that the attribute can has many of the attributes in itself. So the composite attributes has no direct relation with the particular table. It is from the table to the primary attribute. Now we are specifying the attributes that is attaching with the attribute as a relation. So for this name attribute, it is representing a relation which have F name, M name and L name as its attributes. Now the same goes with the address. Let's look at the fields that we can attach with the address attribute. So an address can have their street number, street name, city, state and zip code. Now, why it is important to break these primary attributes into a more range of attributes as a composite attribute? The key idea behind this to do on that we may want to fetch that the persons who are coming from a same state or the persons who doesn't belong to this city. So I have the full address if as a primary attribute, then we cannot fetch these relations or particular parts of the attribute very easily. So if it is better to store these attributes as possible as an atomic one, so that if I want to match any of the conditions or queries on a particular part of this atomic attribute, we can do this very easily. So the main problem of using an ERD is that we can have a more range of these atomic attributes that is attached to the composite attributes. So it is very difficult to look at this, but it is always given simple and clear idea about the logical design of the database. That is why we always choose ERD as a basic designing scheme of a database. Now, how to represent the total participation of a particular entity to the relation. So let's look at this example first. So I am talking about an employee. Let us look at this example for the explanation of the attributes of an employee. So what are the attributes that we can have with an employee entity? So an employee can has his EID as the basic or primary key to the relation, his name, street, city as its address, and phone number as a contact number of the employee. Now, when we are considering an employee to an enterprise, what is the relationship that an employee has with an enterprise? An employee works for the enterprise. Whoever the purpose or whatever the person is, we can talk about an employee is always working for an enterprise. So the relation or the total participation for an employee to the enterprise is the works for relation. So now we will signify how to put this one in an ERD. Now, either an employee manages an employee or either an employee is a worker of that enterprise. So, if there is a relation that helps with the manages, then we can say that we are defining actually the role to the particular enterprise. So, if there is a relationship to this relation that defines manages, that means there are one employee who manages many of the other employees. So there exists a many to one relation. Now in the other part, it can be a worker to the relation. So the double line signifies the total participation, and I am dividing the double line as two relations, that is manages and worker. So not only I am showing you that how to define a total participation for particular one entity to the relationship, but also how to deal with different types of relationships inside that one to signify the role of the employee. So either our employee is a manager or a worker to the particular enterprise. So I am showing you how to define. If there are many types of enterprises to the employee, then we can add it by another line here. So many general cases, the manager manages the employee or an worker as an enterprises of the working. So we will show now as an example of this ERD how to use a total of the role participation in the customer and loan relation. So in this basic ERD, we can see that the loan relation has got the total participation with the borrower. That means a loan, when we are having it as a bank, all the customers are borrower to the relation. So even if there is a customer that hasn't got any loan, if it is identified that loan is the only one that a bank provides, so the customer must be a borrower to the bank if he is attached with the bank as a customer. So in this way, we can define the total relationship from a relation to the relationship idea. Now let us look at an university enterprise relation and to draw it using an ERD. See, this is a big idea that we are implying, so we need to keep in mind very minute things clearly, that we should use as much clear and simple idea about the attributes when designing the final logical view of the enterprise. And then we should use the minimum relationship that we can have as the broader view to the enterprise, not a detailed one. If I want to go to the detailed one, that I will take one section and then make an explanation or an expansion to it. But when I'm talking about a whole idea, I should use the clear attributes as a simpler one, as well as the minimum relationship that we can have within the attributes. Now, before going to the university example, let us see the two things to use this as a diagram representative. So when I am using this in a university example, I should use the divided rectangle as a relation with the attribute name specification. So now we will see that how to use the composite attributes inside an undivided rectangle and how to use that solving of a non-binary relationship or say a ternary relationship. Now here we can see for the composite attributes, it is very easy to represent it just by using an inter tab. Now when I am using the indentation to the particular attribute, then we are specifying that I am going beyond and making it an expansion to the attribute. So the primary key should be underlined as in the previous way. Now the attribute should name and an indentation specifies that these are the complex attributes. Now how to add a multi-valued attribute? Just put in the second braces. So the second braces signifies that the phone number has got a multiple values to the attribute. Again, the DOB can be a normal attribute and H can be a derived attribute. So the derived attribute is followed by an braces start and braces close of a first one. So these are all the representation of another like ERDs which we are using it in this way. Now we will talk about how to establish a relationship which has got more than two entities or considering not a binary but an n-array relationship. The word n-array suggests for that it can be ternary or it can be more than 3, 4, 5, 6 like this way. So the n here represents the number of entities in the relation. So the n-array we are considering ternary, for example, we will see that how to do. We will just add to the relationship another more entity that can be a part of that relation. See, when we are considering a more than one relationship, then actually we are saying that the relationship contributes to all the relation. So it is not always true that one entity can have relationship with another one. It can also be true that one entity or more than one entity can have relationship with another more than one entity. Let us see how to do this one using an example. Say for an instructor and a student, an instructor can be a project guide to a student, and that is true for that many instructor can has the relationship project guide with many students. So I am using the many to many, that has not got any arrows to of this. So an instructor be an project guide to a student. Now what is the other entity that I can use in this relationship? The main key idea of being a project guide is the project. So all the information of a project, I can use it as another entity or relation to the relationship. So we can have the project name, the project instructor, the project student as the attributes of the relation or entity project. So now we have more than two entities that is attached to a relation. So the project guide has relation with an instructor with the project as well as the student who is having the project with the instructor. So that is the ternary relationship that we can exist in an ERD. Now let us go to our university example and see what are the attributes, what are the relations, and what are the relationships that we can attach with this ERD. Let us first look at the entities or the relations in an university enterprise. So first, the university has got departments. So the first relation will be department. Next are the instructors that will teach the students on the subjects. Next are the courses that we can teach on the universities. Next, the department has got different sections that connect to different students. Finally, the students who are the most part of the important one as a university. Now let's look at the relationship that we can have between the entities. First, the instructor can be the advisor of a student. So the advisor relationship lies between the instructor and the student. Next, an instructor can be the department instructor of a particular department. So the instructor has got an instruct department or depth in relation with the department. Now the department has also got student, that is the group of students belong to a department. So that defines the student depth relation with an department and student. Next, that a section has taken the student. So the text relationship lies between a section and a student. Now the section and the instructor has got teachers relationship in this because the instructor teaches in a section. Now the course is from the department at the department courses, like physics department has got 5 courses, chemistry department has got 6 courses. So the course department is the relation between the course and department. Now let's look at the more extensions. A section and a course has got the complex at relationship between them. So that is a derived relationship. So that has got the section courses, that a section can only have courses because it belongs to a department, and the department has also got sections. So that is why it is a derived relationship or a complex relationship. We will represent it with a double diamond. Now we can always see a relationship with another relation, but also a relationship with the same relation. Say that a course requires some of the courses as a prerequisite. That means if a student has got this prerequisite courses, then only he can get admitted to the new courses. So we can simply add it like the relationship with this one as a loop. So we can do this. So the prereq relationship lies with this courses relation as a loop or the self relationship. Now the grade can be a derived attribute that we can have from this student. So we can add it like so it is being attached to the relationship text that in an extra part or as a derived attribute from the student. So if the total credit is given, we can derive the grade, and also the grade can be attribute attached to the text relationship as an individual one. So that is the basic logical relationship idea on a university enterprise to the ERD. So that is all for the entity relationship diagram, basic structure and representation. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.